Hello, everyone, and thank you for joining us today. Let's give everyone just a couple more minutes to join, and we'll be starting momentarily. Okay, let's get started. So, hi, everyone, and thank you for joining us today. In the webinar today, we will talk about chain of thought prompting and how you can use it to enhance your LLMs. My name is Iris Zarecki, and I'm a product marketing director here at K2View. And I have an amazing speaker with me today, Hod Rotem, our Chief Product Evangelist at K2View. Great to have you here, Hod.
Hey, Iris. Thanks for having me. I'm really excited to be here.
Great. So while we're waiting for more people to join, let's start a quick poll. Is it up yet? Yes. So we wanted to get your involvement, understand your involvement with chain of thought prompting. Is it a brand new concept for you, or are you already using it in production in your GenAI project? Please use the vote button, the vote tab below the screen to participate. I think people are starting to come. Let's see. Yes, I see some responses coming in. Don't be shy. Tell us what you know and what you want to learn about chain of thought prompting. Right. So let's give everybody a couple more minutes and then we'll close the poll. Great. Thank you, guys. Interesting. Right now, 50% are saying they know what it is, but not doing anything with it yet. Great. So I think you'll learn a lot in the webinar today. Okay. Interesting results. Okay, let's close the poll. And I'm showing you here results from a recent poll that we ran at K2View. It's not live yet. It will be published in the next couple of weeks. We call it the K2View 2024 GenAI Data Gap Report. And in this report, we're examining how organizations are using data, and specifically structured enterprise data, to enhance their GenAI application. So like I said, the report will be published within a couple of weeks, but follow our LinkedIn page and get your copy. And in the report, we asked a very similar question to the one we asked you in the poll. We asked you, what's your involvement? And actually, we were surprised to see a lot of people, 56%, already involved to some extent, and even 24% involved extensively. This is somewhat different from the results we see here. I think today we see more people that heard about the topic, but didn't use it in practice yet. So I think this webinar today is going to be a great place to learn and look at a real example of how we use chain of thought prompting at K2View. Good. So let's get started, Hod. So moving on to the next slide, the agenda. In the webinar today, we're going to talk about what is chain of thought prompting and how to use it, how does it work, the benefits and also some of the challenges with chain of thought prompting. And I think the most important part or interesting part of the webinar is a case study where Hod will show us our K2View GenAI data fusion product and how it uses chain of thought prompting to optimize customer support. And of course, at the end, we'll take some questions from the audience. So I want to remind you that you can use the questions tab below the screen to submit your questions. You can start submitting your questions right now, but we will address as many as we can at the end of the session. So with that, let's get started. Okay, so there's a famous 2022 article about chain of thought. It's called Chain of Thought Prompting Elicits Reasoning in Large Language Models. It's from 2022, and I think they were the first ones that coined the term chain of thought, and they defined it, as you can see here in the box, as a series of intermediate reasoning steps that significantly improve the ability of LLMs to perform complex reasoning. And this is the most famous example that they gave in the same article from 2022. And in the article, you see that they're trying to solve a mathematical question. I highlighted it in yellow for you. And the question is, the cafeteria had 23 apples. If they used 20 to make lunch and bought 6 more, how many apples do they have? Now, as humans, we are assuming that computer answers are correct and consistent always. Like, when was the last time your pocket calculator had to apologize for a mistake? Doesn't happen. But as we know, this is not true, and this is not how it works with LLMs. And we can see here that in the first trial, in the first attempt on the left-hand side, actually the LLM failed and the result is wrong. In the second attempt, when we used chain of thought prompting and gave the LLM an example of how to break down the problem into intermediate steps, now the answer was correct. So this is what chain of thought prompting is all about, breaking a question into steps. Now look what happened here, Hod. I tried and this same question just last week with ChatGPT, with my lovely ChatGPT. And now what I see here is that ChatGPT already has chain of thought built into the model. In other words, it's explaining to me how the problem is broken down into steps, and also explaining the math along the way. And of course, the result is correct. So, Hod, if LLMs do chain of thought prompting themselves today, is this topic still relevant?
It's a great question here. What we're seeing here on the slide, this is how chain of thought started. A couple of years back, the idea was very simple. Let's try to get the LLM to think more like humans do. Consider when we're being presented with a complex problem, we intuitively break it down into sub problems, more simpler and more intuitive sub problems. We solve them, and then we use this to solve the overall problem. And this was the intent here as well, asking the LLM to break down the complex problem into smaller subtasks, resolving each one, providing the reasoning, how it derived the problem, the answer, and use that to answer the entire question. Now, what's important to understand is that just by asking LLM to break down the problem, it doesn't guarantee that it's going to produce an accurate question or an accurate answer, sorry. And we have another example here that possibly even today will cause LLMs to provide incorrect answer. We're about to ask our good old ChatGPT a very simple logical question. Which one of these two steak cooking recipes will take less time to cook? Option number one is an oven-based option. We're going to dry brine the steak for a couple of hours. We're going to sear it 90 seconds on each side. We're going to let it cool for 10 minutes. We're going to put it in the oven for 45 minutes before letting it rest for 10 more minutes before serving. The second method, the second recipe, is a sous vide option. We're going to vacuum seal it. We're going to sous vide it for 150 minutes and 2.5 hours. That's 2.5 hours. And then we're going to take it out, sear 2 minutes on each side, and serve. Now, my kids are really hungry, and I need to figure out which of these two methods will take less time to cook before all hell breaks loose. So I'm about to ask ChatGPT this exact question. I'm going to try and share my screen here for a second. And Iris, can you let me know if we can see this?
Yes.
Okay, this is the exact same question. which one of these two recipes will take less time to cook? And notice that I'm asking ChatGPT to break down and provide reasoning to how it derived its answers. Now this is live, so I don't know what ChatGPT will answer here. It might be correct, it might not be correct. I can already see a couple of inconsistency just by looking at it. For once, is actually telling me that the overall result for cooking the oven methods is 2 hours and 8 minutes. It actually derived the answer correctly here, 268 minutes, because it took the 2 hour for dry brining and added the cooling and the oven time, but somehow it got the calculation incorrect. It resulted in 2 hours and 8 minutes, which because of that mistake, it decided that the overall time is actually shorted for the oven recipe and telling me that this is going to be faster. Now, interestingly enough, if I'm going to reshare the slide here for a second, I had asked the exact same question to ChatGPT last week, and you can see that it provides a different answer. I try to highlight the inconsistency in color here. So we're going top to bottom. We can see at the top that first it's telling me that it's going to take between 10 and 15 minutes for preheating the oven. Now, this is not necessarily a sequential task. I can preheat the oven while the steak is cooling from the previous task. And then it tells me that it's going to exclude brining. Unlike the preheating that I can do in parallel, brining is not one of those tasks. I have to brine for the steak to be good. And then it actually calculates the time incorrectly. In our example that we just ran live, it says 2 hours and 68 minutes, 3 hours and 8 minutes, which is the correct time, by the way. But when I ran it a few days ago, it said 2 hours and 16, between 16 and 21 minutes. Now, if we run the math ourselves, and we can look at the box on the right side, it is 3 hours and 8 minutes. So the fact that it derived incorrect number is problematic. It also miscalculated on the second option, the sous vide. Notice that it's telling us that we're going to sous vide for 2.5 hours, but the overall cooking time for sous vide is 2 hours and 14 minutes. That makes no sense. Now, because of these discrepancies, because of this miscalculation, in this scenario, it's actually telling me that the sous vide is going to take less time. And this is repeatable every time that we're going to run. We're going to potentially get a different answer. I ran it again a few days ago, and in this case, he did actually calculate the sous vide correctly. Second paragraph from the bottom, you can see 2 hours and 39 minutes, which resulted in him deciding again that recipe 1 is faster. So all this to say is that the original intent of asking LLM to break down to subtasks isn't enough to ensure that the answer will be correct. Yes, it did significantly improve what's called as a solve rate, the success rate of the answer. And it allows us to understand how LLM thinks and how it breaks it down to smaller subtasks and the reasoning, which was a lot more applicable to solving complex tasks. But there were some notable drawbacks that we need to be aware of. The first one is that it didn't really give us the ability to control the process. Yes, we've taken that complex task and we've broken it into subtasks, but influencing the processing each subtask is somewhat challenging. In fact, if I go back to the previous slide and look at the right side of the highlighted items, I could help fix some of these items. I can add verbiage, what's known as prompt engineering, and tell the LLM, hey, exclude the preheating time and include the brining time. But I don't know how I can fix the miscalculation of him thinking that it only takes 2 hours and 16 minutes. The truth is that I don't even know how it arrived to that calculation. So it's harder to fix. In other words, the fact that it's still all managed by one LLM makes it hard for me to debug the process and influence the different stages. Another very important drawback of that original approach was the fact that I can't really decide what solves each substate. It's still all managed by one big LLM, and it might be the case that different stages are better suited for different processes, maybe even different modules. So maybe ChatGPT is extremely good at understanding the intent of the question, what the customer meant when he asked the question. But maybe Gemini is better at forming the answer, and Llama might be cheaper than Gemini. And in my case, I'm okay with the quality of the answer being a little less good as long as I can control the cost. Maybe the customer wants the answer in Spanish or Hindu, and Claude is a lot better at translating to different languages. In other words, the fact that it's all managed by one process, at least in the original intent, didn't allow me to control the process, where if I had broken it to individual subtasks and be able to control what process manages each subtask, I could produce a much more efficient, more performant, and cheaper chain overall. Now, these challenges, it's what led to the evolution, the next stage of the evolution in the chain of thought. Iris, why don't you tell us about that?
Yes. So chain of thought evolved into prompt chaining. And you can see the definition in the box on the right-hand side. It's a method of linking multiple prompts together to achieve a more complex or refined outcome. And here's a very, very simple example. If I'm trying to generate a detailed report about something, I can ask the LLM to generate an outline first, and then I can ask the LLM to expand on section 1, section 2, section 3, and section 4. So I've broken down the problem into multiple steps. Each one is a different prompt and a different step. Now, let's look now at a more complicated and maybe also realistic example. If we want to create a customer chatbot for, let's say, a telco company, and we want the user or the customer to be able to ask any question about himself, about his data. He can ask questions about invoices, about roaming, about network, about international packages, etc., etc. So how do we break down this challenge, this complicated problem, into smaller steps? First, we get the user prompt and we ask the LLM to determine which domain the questions belong to. Is it a question about invoice or maybe a question about an international package? So we ask the LLM to help us determine that domain. And then once we determine the question's domain, we can go into another LLM, which is relevant to that or LM agent that can address these kind of questions. And this is what we can see in the next slide. If we drill down now into one of those domains, let's say again, invoices. So this is an LLM agent that can address questions about invoices. So the first step that you can see on the left-hand side is to ask the LLM, can I answer the question? What does it mean? In other words, it means, do I have the data in order to answer the questions? Now, once I have the required data, I can ask the LLM to now write a response back to the user, which you can see in the bottom. Write a response to the user, listing whatever we need to list. Maybe it's the total amounts that he owes us or the last 3 invoices that he paid. If we don't have the required data, for example, maybe the user asked us a follow-up question on a different domain, or maybe I need to know how long he'll be staying in a foreign country in order to suggest the best package for him. In those cases, I need to get back to the user and ask for some clarifications or get some more information. So this is how potentially an LLM agent trying to address a specific questions from a specific domain will behave. Now, the great thing about chain of thought prompting is that I can use different models, like Hod mentioned before, for each step. For example, when I look at the user request, it might be in different languages. So I might want to use a model that specializes in different languages. Maybe that's Claude to address different languages. To query the data that you can see on the right-hand side, I can use different models to create and execute queries. For example, I can use different models for structured data, which requires SQL, and then separate models, other models to address vector databases, depending on the data that I need to bring on. And to answer the question, write the answer back to the user, I might want to use another model that specializes in languages or maybe a model that can very nicely present a visual representation of the answer with some images. So again, a different model can maybe write the answer. And then lastly, cheaper models. We talked about cost, which is a big concern when it comes to GenAI applications. I might consider cheaper models for some of the steps in order to save costs. Odd?
Yes. Okay, so I think we can see how the ability to break down the complex problem into subtasks and be able to manage it separately can produce significant value, especially around very complex type of scenarios. Now, it turns out that designing and building chain of thought using this approach is really not that complicated when you have the right tooling. We listed here a few best practices that we recommend you consider when you design and build your next chain of thought agent. Starting with the design on the left side, the trick here is it's actually really simple. Start with the end goal. Start with what you want the entire chain to achieve, and then break it down logically to subtasks that are simpler to manage. You then define what each subtask does. What's their responsibility, what's their input structure, what their output structure. You want to pay special attention here to make sure that there are no duplications. You don't duplicate some of the same activities in multiple subtasks. You also assign a team and a process and a technology for that subtask. And yes, it might very well be the case that you will end up having a chain with different subtasks managed by different group of people that are using a different process and a different technology, maybe even a different model to achieve this subtask. In this stage, this is where you actually build those subtasks. You then move to the validation phase. The validation is where you want to pay special attention to make sure that the output of each stage is exposed in the right format, in the right structure, and then the sequential stages know how to consume it correctly. This is where you'll do a lot of prompt engineering to kind of fine tune, refine each stage. And lastly, you get to testing it. Now, there are a couple of very important things or best practices you want to consider when you test. First is make sure you test on a very wide and diverse set of inputs. This is especially important when the input to your chain is unknown. Iris was mentioning an example of a chatbot. We don't really know what the customer is going to ask. So the more wide and diverse your test cases are, the higher the chance that your chain will produce the right answer. The other best practice around testing is, and this is one that we highly recommend, is to invest early in the process in automating the testing. You have now taken your chain, you broke it into subtasks. Might be the case that each subtask is managed by a different team using a different technology and different module, and they all build and test their own model. But you need a mechanism to automate the end-to-end testing. So you want to have a platform that enables you to consume a large subset of test cases, hundreds or potentially thousands of scenarios, and it will run it through the entire flow, through the entire chain, evaluating that each stage is performing efficiently and correctly, and that the overall result is improved. And that means that every time you make a change to any of the links in the chain, any of the stages in the chain, you can run full regression testing in an automated test that doesn't just evaluate that the individual stage that had change is performing correctly, but that the overall statistical result of the chain has improved. So guys, we've gone through quite a lot in the past 20 minutes. We started with what was the original intent around the chain of thought and asking the LLM to break down the complex query and provide reasoning and some of the pros and cons that were associated with that approach at the time, and how chain of thought evolved to allow you to control the individual stages and potentially use different processes and teams and modules to control each one. And Iris shared a few examples, and then we finished with a few best practices. I think it's time to maybe see something live here. We're about to share a use case or a test, a demo that is based on an actual K2View customer. Of course, we changed the names and the data in the format, but we'll call this customer Elite Telco. Elite Telco, it's a telecommunication company. It offers standard internet, phone, and TV services to many of its millions of customers, one of which is David, who is currently having a home internet issue. Now, his home internet issue is related to the fact that he hasn't paid invoices in a while. There's outstanding balance on his account, and coincidentally, there's also an active outage right now impacting him. Now, these reasons are important. We'll explain why in a couple of minutes. Now, Elite Telco wanted to build a customer support LLM-based chatbot that its users, David included, can interact with to understand and resolve their issues. And they chose K2View. We have a product called GenAI Data Fusion. They chose GenAI Data Fusion to build an agent that, using chain of thought, orchestrate the entire communication between the chatbot, where David is asking a question, the LLM, or LLMs, plural, and most importantly, all of their enterprise data. So our GenAI data Fusion product is based on our data management platform. It's a platform that enables you to interact with all your enterprise data, be structured, unstructured, relational, non-relational, and collect and integrate it and create contextual view of your business in a way that is very efficient for LLM to interact with. Now, why is this stage so important? Because if we look at the issue that David is having, the unpaid balances and active outages, we need access to real-time data in order to understand that these issues, his issues are caused by these factors. And that means that in our chain of thought, we have a link, we have a stage that is responsible to go and collect and integrate data across the enterprise, structured, unstructured, relational, non-relational, and prepare this data for the LLM in order for the LLM to be able to answer David's question of why his internet is down. Now, without this stage, LLM will likely not be able to produce a very valuable answer. In fact, let's simulate this exact scenario. Let's go back and share our ChatGPT. Iris, kindly let me know that we can see this.
Yes, we can see them.
Thank you. And let's simulate David asking the support bot a question. Hi, my home internet has stopped working. Can you help? Spelling mistake. Help me. Now, this is live. I don't know what ChatGPT will respond, but I can assume a couple of things. First, it will probably provide a really good answer. It's a wonderful answer, right? It says, check your modern router, restart the equipment, check the connections, verify network settings, meaning it's all great, but it really doesn't apply to David's issue. David has an outstanding balance and an outage. These are all great recommendations, but it doesn't solve David's issue. Not having this link in the chain that has access to data and can prepare and correlate this data means that at the end, David will likely want to talk to an agent, which defines defeats the purpose of building the chatbot. If at the end David is talking to an agent, why did we build the chatbot? Now let's take the exact same question and let's run it on the Elite Telco customer support bot that sits on top of the K2View data, GenAI Data Fusion, that is interacting with the enterprise data, with the chatbot, and with the exact same ChatGPT LLM behind the scenes. So the model is actually the exact same model. Now, before I paste the question that we asked, before I click the return button, I'm going to open a tab here called History. Because in a second, as soon as I click the return button, it's going to start detailing the stages in the chain that we've gone through in order to respond to this question. So let me click enter, and we'll be able to see it's already done several stages, 5, and in a second, hopefully, by the way, it will collect and retrieve all the information needed, and will reply to the customer. Here's the reply back on the screen. Before we dive into the reply, into the stages, let's just look quickly at the reply. Let's see how more personalized and valuable it is to David. We call that grounded information, grounded reply, because it tells it exactly what problem we have. You have an outstanding invoice. You have outage that is impacting you. Potentially enough information to David say, okay, I know what's going on. I know what I need to do. He doesn't need to talk to an agent. Now, if we look here on the right side, we can see the different stages that we've gone through in order to answer the question. Now, each one of these boxes is a stage, and a stage might be comprised of multiple sub-stages. The first few stages is what we K2View call building the customer story. The idea is that we have knowledge about the enterprise data. We know what data is made available. So I can integrate and consume and prepare this data for the LLM. But K2View does that in a dynamic way. We know, for example, that very often invoices and outages impact customer service. So it makes sense to prepare this information to the LLM, say, hey, here's the information about David's invoices and outages and customer information. See if it helps you answer his question. The first stage here is actually working with an LLM to build a query that we will execute on K2View to retrieve the invoices and the outages. And if I break down this stage to subtasks, and I clicked on it and you can see there are a lot of subtasks executed in this stage, starting with the initialization of the LLM. You guys might be aware that LLMs are stateless. They don't remember what happened a second ago. So every time I interact with that, I need to provide it state and context. Your name is Elite Personal Helper, your Curtis Customer Service Bot for Elite Telco. Here are some phone numbers that you might choose to reference later on. Because we have access to the data, we can help prioritize how to address customer concern. Start by looking at the invoices, and then look at outages, and then address other issues. And then we dynamically provide metadata information to the LLM about what data is made available. We're telling him there is a table in K2View called customer, and this is the business description. And it might be connected to an invoice table using this referential integrity, even though they might be derived from different technologies and different applications. And here's the business definition for each column, and here's the valid values for each column. And then we're asking the LLM, gather data regarding unpaid customer invoices and active outages, to which the LLM responds with a query, uses the valid values and the metadata that we provided. It creates a query for me, for K2View, to go and execute on top of the data we collected in order to prepare to the LLM the data that you will need to answer the customer query. And here we do, in this stage number 2, the by the way is executed in parallel to stage number 1. We're collecting some basic customer information so the LLM knows how to address the customer. And then in the next stage, we use the data that we collected to summarize the information that we have so far. So if I go to stage 3, I can see that we got the SQL from the LLM. We then executed in K2View the SQL. We got a bunch of invoices back. And at the end of this, we're actually asking the LLM, please summarize the gathered data. And in this stage, the LLM will take this information and provide a summary that is a lot easier to consume and understand and debug. Here are the invoices and outages information. And here are the customer basic information. All of this is what we call the customer story, preparing the data that the LLM will need in order to eventually answer the question. And all of these are done in different stages in our chain of thought. We then get to stage number 5, which is, in our example, probably the most important one. We go back to the LLM and we say, hey, considering the customer story that we prepared and the question that the customer had asked, reflect on this data and tell us if you have enough in order to answer the customer question. We ask LLM here to answer one of 4 options. Option number 1, you need more data from K2View. K2View will go to the enterprise, collect the relevant data. Option number 2, you have all the data that you need to address the customer issue. 3, you might need to ask the customer for more information, some clarifying question. Or 4, the customer finished the conversation, we can close the discussion. And LLM here says, given the information that you provided in the previous stages, I'm answering number 2, meaning I have the data that I need to answer the question. And as a result of that, in the sequential stage, we will ask the LLM to prepare an answer. And that's what the LLM returned. Hello, I'm here to help you. Exact same information that we're seeing here on the screen. Now, naturally, a lot had to happen in order to build this agent and to prepare the data. And it all starts with our designer. It all starts with how we perceive the enterprise data to prepare to the LLM. In this example, we can see that we built a contextual view of customer across the enterprise data. We collected information from a CRM, that is a SaaS system, and technology number one, that included some cases and notes and a few other things. And we integrated to another application and technology. This is the billing application in DB2 that included invoices and payments, and even to the Oracle network management, that is outages. And having this contextual 360 view of all the enterprise data about a customer now gives the LLM the ability to integrate data across these technologies. In fact, if we look at the question that the SQL that the LLM generated, he told us to join invoices with subscriber and outages. These are three tables derived from three different applications in three different technologies. K2View enables that. Now, all of that information is now ready. The entire orchestration of how the agent works, how we communicate with the chatbot, with the LLM, with the data that we've collected, is all managed in K2View in what we call orchestration flow. This is our agent designer. It's a drag and drop visual type of designer, allowing you to build very effective agent. And we can see the different stages and sub-stages that we've done here to create this chain of thought, starting with initializing the LLM. Your name is Elite Personal Helper, your Curtis customer bot for Elite Telco. Here are the phone numbers that you have to refer to. Here are the order in which you should address customer concern. We have access to data. We know that the first thing we want to do is look at outstanding payment and then active outages. And then we use this to build the customer story. This is a stage of building the customer story, which in terms actually is divided into two sub-stages to collect general information about the customer and collect invoice and payments. Each one is using LLM to prepare and collect the data. After we've built the customer story and we initialize the LLM, we then ask the LLM to reflect. Do you have all the data that you need in order to answer the customer question? The answer is 2, which means I have all the data. So we follow up with a stage asking him to prepare the answer to the customer, to which he says, hello, I'm here to help you, and all the information that we've seen on the screen. And lastly, the last stage in our chain of thought here is to actually persist the state. So we kind of take audit of everything that had happened, all the summaries that we've generated, and we store it for the next iteration. And that might be the customer asking a question 10 seconds after. Maybe he'll come back a few months after and ask a follow-up question. All of that information is audited and maintained in K2View. And that means that any follow-up question that the customer would ask will go through this chain of thought agent. Let's ask another question here. What is my home internet outstanding balance amount? I think I have a spelling mistake here. Outstanding. Okay. And before I click the play button, let's go. The last stage that we had before was stage number 6. And now we can see that the LLM answered number 2. I have all the data that I need to generate the answer. Here it is. We went to the sources. We collected in real time your data, your billing information. We identified that you have 3 months worth of $79.99 that you owe. The overall amount is $239. This is what is responding. And if we go to the behind the scenes again, we can see that this time it didn't start from scratch. It had already maintained the state from the previous question. The question that we had, hey, my home internet stopped working, and we use that as our customer story, ask the LLM to again reflect, do you have all the information that you need? Maybe the LLM will say, no, I need to collect additional data. Maybe in this case, he answered number 2, I have all the data that I need, I can reply, to which we ask, build the answer, and it says, certainly, your outstanding information, this is exactly what we've just seen on the screen. And lastly, we then persist the state for the follow-up discussion. So I know we've gone through quite a lot. Let me...
Wow, God, that was impressive.
Let me reshare the slides and try to summarize what we've just seen. This is a simplistic diagram of kind of the stages that we've gone through. Starting from the left side, the user, David, putting in the prompt, my Wi-Fi isn't working. Then it goes to the K2View agent, and we can see some of the breakdown of the stages, starting with initializing the LLM, collecting information about the company, your name is Elite Personal Helper, phone numbers, website, looking at the data to understanding what priority we should address the customer's issue. First, look at the outstanding invoices, then the outages, etc. We even use the 360 contextual view that we built about a customer to create metadata that we dynamically share with the LLM. We use text-to-SQL to ask the LLM, prepare a statement to retrieve the invoices and the outage, prepare a statement to collect customer information. And the added value here is that this is done dynamically, meaning you don't have to predefine thousands and tens of thousands of SQL how to retrieve the data, and then you have to manage those. And every time the data structure might change in the source system, now you need to go and change all of that. This is done completely dynamically, and each one of these stages uses LLM for different purposes and might be using a different LLM. Maybe to create the SQL statement, you should use ChatGPT 3.5. It's a lot cheaper and it does a great job as well. But to translate to another language, you go back to Claude. And then we ask the LLM, do you have all the information that you need? The answer is yes. We will summarize the information, keep the state of the discussion for future use, and respond to the chatbot. Okay, Iris, I think we're good to maybe take some questions from the audience.
Yes, great. Thank you, Hod. So we do have a couple of minutes to take some questions from the audience. I want to remind everyone that to please use the questions tab below the screen to submit your questions. I also want to use this opportunity to remind you that you will receive a recording of this session in the next 24, 48 hours. And we do have some attachments for you in the attachment tab below the screen, which include a blog post we wrote about chain of thought prompting, today's slides, and a little bit more information about our product, K2View GenAI Data Fusion that Hod presented. And lastly, if you want to see a demo, a real demo of the full product, we'll be happy to get in touch with you. Just answer the next call if you want to see a demo, and we'll get in touch with you after the webinar. So with that, Hod, I see that some questions are already coming in. Are you ready?
Let's go.
Okay, so I think the first question that I want to take here is this. Is the K2View product that you showed us here, is it a RAG framework or a chain of thought framework?
That's a good question. It's not this or this. It's actually both. Our product is called GenAI Data Fusion. This is a product to design and build agents. And it sits on top of our data management platform, a platform called Fabric, that it kind of sits on top of your enterprise and integrates and consumes and collect and transform all the data. And that gives our agent the ability to add a stage that retrieves the data. It actually uses K2View's data management platform to retrieve the relevant data, and that can be structured, unstructured, relation, and unrelation. It can be that the agent will go to a vector database or a graph database. It can be that you will actually go through K2View to the structured data in the enterprise. So the GenAI Data Fusion is an agent designer that mostly use chain of thought. You don't have to use chain of thought technique, but it's mostly used chain of thought to build the agent, and it resides on a data management platform that enables the agent to do RAG.
Got it. Okay, let's move on to the next question, Hod. I see that some more questions are piling up, so let's try to take as many as we can. The second question that I want to pose to you is, how can you ensure security and privacy when using chain of thought?
Okay, also a wonderful question. First, I want to say chain of thought doesn't ensure security and privacy. However, you should absolutely include security and privacy as part of your chain of thought design. Now, K2View has a lot of functionality around security and privacy. Maybe I'll touch on just a couple. The first one is masking functionality. And let me reshare my screen for a second so we can look at something that, actually, let me go back to the previous slide where we were seeing the diagram before I share my screen. So when he talks about masking, K2View has some very advanced masking functionality, starting off with the ability to scan and discover PII, the ability to catalog and classify the data, and the ability to automate the masking process. And that means that we can include stages in our chain of thought that takes care of security. If you can see on the right side of the diagram, there are 3 blue boxes. The middle one is called masked data. We can actually include a stage that masks the data that we've collected from the enterprise before it is sent to the LLM. We still see in the market that some customers are not too sure about sharing real PII information with the LLM. So K2View does give you the ability to actually mask the data before it's sent into the LLM. And then we get the response back to the LLM. We unmask the data before sending it back to the customer. We even enable what we call dynamic masking, which means that depending on who's asking the question, we might decide to mask or unmask the data. So if David is asking a question, he's entitled to see his real information. We will, after we unmask the data that we got from the LLM, we'll return the real information. But if maybe it's an agent asking on David's behalf, we might want to mask some of David's information. The agent is not privy to every piece of data about David. So we can dynamically mask the data before we interact with the different components. Now, another very, very important feature and functionality of K2View around security is what data we give the LLM access to. And here I'm going to, again, share my screen and go back to where we were talking about how we contextually build the 360 view of a customer across the enterprise, collecting information from CRM and billing and other, and etc. Now, the secret sauce in K2View is that it doesn't just contextually build the structure. It physically manages the data in that way. What we do is we take all of this structure for one single customer, David, and we manage and store it in a secure micro database. So essentially, David has its own micro database. Think of it like a micro lake that all of David's information in it, and Hod has another micro database, and Iris has a third one, and they're all managed and encrypted separately. And why is that important? It's important because when we give access to LLM to the data, we give access to the specific micro database that is associated with the customer who's asking the question. In other words, if David is asking a question, the only physical access that LLM has is to the micro database that holds David information. It doesn't have access to the micro database that holds Iris information. This is a big security advantage because if you consider the standard mechanism nowadays for RAG, where kind of put all the data in a vector database or a graph database, now the LLM can potentially ask information about David, but from the graph database or the vector database, and get information about Iris. With K2View, it's not possible. LLM only has access to the specific micro database from whom the chat is about.
Great. Hod, if you can stay here for a minute, there's one question, an additional question from the audience about how does K2View harmonize the data? So do we do it here on the micro database level?
This is exactly where we do this. This is where you design what data you take from each system and application and technology. And it might be that this device table is derived from a file, and this invoice table is a microservice or web service, or store procedures or queues or mainframes or structured or unstructured or relational or non-relational database. You kind of create a business orchestration of how the data relates to one another, and each one of these objects, you can also control how you actually move data from the different source system to K2View. And again, it's all drag and drop. It's all very business oriented. It's all very visual. You can debug and see how the data flows through all the different stages of data retrieval. So yes, integrating data across your enterprise, there's big advantage for K2View because we don't really use coding. Yes, by the way, you can use coding. You can develop in Java if you wanted and put breakpoints and step in and step out and all this functionality. But you don't really need to. Most of the data integration functionality can be done using this drag and drop type of business orchestrator.
Great, thank you. I think we are running out of time a little bit. We have time for maybe one or two questions. Let's see. There's one more that seems interesting. I know that hallucination is a big deal when it comes to GenAI. So is chain of thought prompting able to reduce hallucinations?
In a way, yes. Let's first understand kind of generally what type of hallucinations we have, right? So the first hallucination is derived from the fact that LLM just doesn't have the data, right? So it's making stuff up. And chain of thought is a very critical tool in preparing the right data, especially in the example that we've just seen here with K2View, collecting and preparing the right data to the LLM. And the more data you give it, the more accurate the response will be. So by using chain of thought that includes RAG, that includes retrieval augmented generation, you can actually bring the relevant data and elevate the assurance that the LLM will produce the right answer without hallucination. This is one type of hallucination that LLM just doesn't have data and it's making it up. The other type of hallucination is where LLM has data, but it's responding with the incorrect one. And that's an example of what we talked about a minute or two ago when, for example, you use a big vector database and David is asking a question about his invoices, but somehow the LLM using similarity search retrieved from the vector database invoices about Iris. So it does have data, it's producing accurate answers for that data, but that data doesn't belong to David. So it's hallucinating and providing incorrect information at the end. And this is where this concept of the micro database plays in and is so critical. It ensures that the security aspect, you're not providing incorrect information about Iris to David, but also it helps significantly with hallucination.
Great. Thank you very much, Hod. I think we are running out of time, so we'll try to get back to everybody else with questions that we didn't address today. And thank you very much, Hod. I think this was an amazing demo. And thank you, everyone, for joining us today.
Thank you all.
See you in the next webinar.